All right, let's talk about one of the most fundamental yet so often misunderstood parts of API testing, the humble HTTP status code. If you've ever found yourself totally stumped by a failed test, well, this is for you.
We have all been there. A test run goes red, the log just says failed, and you're left digging through mountains of code just looking for clues. It feels like pure guesswork, right? But what if I told you the single most important clue was staring you right in the face the whole time?
That's right. The key to knowing exactly what went right, or more importantly, precisely what went wrong, is that little 3-digit status code. And honestly, mastering these is what separates the good engineers from the truly great ones.
To really get this, let's think of it in a way we can all understand. Sending an API request is a lot like placing an order at a restaurant. And that status code you get back, well, that's the instant, universal signal from the kitchen telling you exactly what's up with your order.
What's so great about this analogy is how it simplifies the happy path. A 200 OK is basically the kitchen shouting, "Order up! Here's the exact dish you asked for." Simple. But a 201 created. Now this is a subtle but absolutely crucial difference. It's more like the kitchen saying, "We got your request for that new special, and hey, it's now officially on the menu." See? Both are a success, but the type of success is different. And being that specific, that's a pro move.
And this is where the analogy really shines when things go wrong. A 400 bad request. That's the kitchen telling the waiter, "I can't even read this ticket. Your handwriting is terrible. Go fix it." The problem is with the order itself. It's a client-side problem. But a 500 internal server error? Whoa, that's a total catastrophe in the kitchen. It has nothing to do with your order. The server itself is literally on fire.
So, okay, fun analogy, but why does this really matter so much? Because understanding these codes instantly transforms you from a detective, randomly looking for clues, into a surgeon making a precise diagnosis. It tells you exactly where to look first.
And that's the bottom line. This isn't just about getting a green checkmark on your tests. This is about speed. It's about efficiency. Knowing a 404 from a 503 instantly tells you whether you need to fix your request or if you need to go tap the back-end team on the shoulder and ask them to check the server logs. That alone will save you hours, I promise.
Seriously, nailing this skill makes your tests smarter, your debugging exponentially faster, and your whole team more effective. You've got this. It's way simpler than you think.
So let's get practical. Let's see how this all translates into actual test code. We're going to look at writing assertions that validate these codes with absolute precision. Before we dive in, let's just make sure we're clear on one term: a test assertion. All it is your test asking a simple question. Did I get the exact status code I was expecting for this specific scenario? It's the moment of truth for your test. A professional's workflow is always deliberate, always planned. First, you define exactly what should happen. Then you build the request to trigger that exact scenario. You run it, and this is the most critical part, you assert that the status code you get back is exactly what you predicted. No guesswork.
Okay, here's a perfect example in Java with rest assured. Notice the specificity here. For a simple GET request, yeah, we assert status code 200. But look at that second one. When we post a new user, we're not just looking for any success. We are asserting the exact code for resource creation, status code 201. This is a non-negotiable best practice. And this is just as vital when we're testing for failure. Here in Postman, we are deliberately requesting a user that we know doesn't exist. Our test only passes if the API correctly tells us, hey, 404, not found. We're not testing for success here. We're testing that the API handles its errors gracefully and predictably.
And that brings us to the most important distinction in all of API error handling: the 400 series versus the 500 series, or as I like to call it, the blame game. This slide lays it out perfectly. It's so simple. If you get a 400x error, the server is politely telling you, hey, the problem's on your end. Maybe your request was malformed or you weren't authenticated. Your job is to fix your request. But if you get a 500x error, the server is saying, it's not you, it's me. The problem is internal, and your only real move is to check the logs on that side. And listen up, because here's an insider tip that you see from the top 1% of QA engineers, and it will save you so many headaches. Retrying a 4xx error is completely pointless. The server has already told you the request is flawed.
Sending the same broken request over and over again isn't going to magically fix it. You have to actually change the request itself.
Okay, now that you're thinking like a pro, let's quickly cover the common traps that trip up everyone else, because knowing what not to do is just as important. These right here are the big 4 rookie mistakes. Being lazy and just using 200 for all success codes. Using a generic 400 for every type of client error. Forgetting to check for data leaks in your error messages. And of course, the big one we just talked about, automatically retrying 4xx errors. Avoid these, and you will be debugging at lightning speed.
All right, let's wrap this up. Let's boil everything we've talked about down into a pro-level mindset that you can start using today.
Here are your 3 golden rules. 1, be hyper-specific in your assertions. Don't just check for something in the 200s, check for a 201. 2, immediately know the difference between a 4xx and a 5xx error. It's your roadmap for debugging. And 3, make friends with negative testing. Proving an application handles errors correctly is just as valuable as proving it handles success.
And that's really the bottom line. I'm not kidding. It might seem basic, but truly mastering the language of HTTP status codes puts you in the top tier of automation engineers. It is a foundational skill that pays off on every single test you ever write. So the next time you see a failed test, what's the very first thing you're going to look for?